Hello everyone and welcome to a new tutorial on Cloud Compare. Today I'm going to teach you how to create your own maps and your own representations and transfer those visualizations or maps into a Cloud Compare into a point cloud using Cloud Compare. So the tutorial today will explore other options on how you can transfer your own colors, your own maps, or your own representations or visualizations into a point cloud. So before, if you remember, as I show you in my YouTube channel. Let me go to my YouTube channel. In my YouTube channel, I already explained how to do the coloring process using two methods. Um, While it's loading, I will explain these two methods. The first method is using Cloud Compare interpolation. So edit colors and interpolate colors, or scalar fields and interpolate from another entity. Um, and the other method is using LAS tools in QGIS. So it's here using LAS.Colour in QGIS. So these are the two main methods I taught in my YouTube channel. But today it's slightly different. Let's imagine that you want to create your own map, or you found this map, for example, in AURIN portal. AURIN portal is the Australian National Research Infrastructure Network. Let's imagine you found information on the different quality of the soils, or different type of vegetation, or different population density, and you want to transfer this information into the cloud, into the point cloud. It's taking a bit to load. So meanwhile it's loading, then, for example, I found this image of the national arboretum with the different national species. And what if you want to transfer this image into the Cloud Compare, or modify and show with different colors different type of species? So this is what I did. I saved that image as a JPEG, and then after I edited the different colors of the plant species. As you can see, I just did very randomly. I just chose between red, blue, and green, just to represent different type of conditions. So you can create any map you want. For example, the blue can be a species that are endangered species. The green are for example, endemic species, and the blue may be contaminated species. Or, for example, you want to represent different type of soils, so with different colors. So that's what I did, and I saved this in different formats. I save it as TIFF, as PNG, and JPEG. So the tutorial of today will concentrate on how to basically represent those and transfer that information into the Cloud Compare. So first step to follow is like the logic or the workflow will be: first we need to georeference that image or that master plan. After it's georeferenced, we can transfer it into the Cloud Compare using the methods that I showed before. So let's do it. It's very straightforward, but it will take a bit of time, the georeferencing. So I have opened two software. One is the QGIS, the other is the ArcGIS. And I will teach how quickly georeferencing both of them, and then export this to Cloud Compare. Okay, and interpolate the values. So the first thing I need to do is, like, in order just to have the image added here, I have image and data sets, but how to transfer image or give a geolocation if you don't have any reference. So the first step is just to have a shapefile, or a shapefile or vector or data set or whatever, that it already has the geolocation. You can do this by going, for example, to AURIN portal and logging. If you work for a organization company, different companies that have agreement with AURIN, or in the university, it's easy for you to log in. And then you need to select the area or use a bounding box. Now I will show you quickly how to do that. I think it's a bit unresponsive, my computer. So let me see what I can do. So the first thing is I want to transfer the image, which is the Arboretum of Australia, which is in Canberra. So I'm going there to Canberra. I'm trying to find a location. It's good. And only thing is I need to change the bounding box, or you can change your area selection. I would choose bounding box and then change the bounding box to, oh, okay. I want to bring this to Canberra. Okay, it's much easier like this. Okay, that's it. Reduce this size. So the arboretum is located in this part, and I just want to get the bounding box. And then once you have defined the bounding box, just click there. It's done. I want any special data sets that can help me to give the reference. So it could be the, for example, this is from a previous work. I will delete it. Where it is, remove data set. So I want just to find a very simple data set. It could be an LGA, could be a street network, etc. So you just put in the keyword, search, and it's taking a bit. It will find. So you have here an LGA. Just be sure that whatever you download has geographic geometry. Otherwise, you're just downloading CSV comma separated value. So like this case. So let's imagine we can grab some. Let me see if I can find something like a power line. No. Street network. Street network. Oh yeah, big roads. Why is big roads there anyway? Transport and topography street network. Okay, it has geometry. Just want the geometry, and or you can choose all attributes, but it doesn't matter. I just want something simple, and then add and go to the data set, and then I will just put okay. You have to agree on the agreement. Otherwise, you can get any data set, a special data set that give you the location, generic location of that place. Okay, once you have this, it's added there. You just right click in this symbol icon, and then you put download shapefile. And here you have your shapefile. So you go to the folder, choose copy. I will copy to where I have in my folder, Cloud Compare. And then I will put, oh, sorry. I will paste here, and then I will extract that, extract here. And once I have it there, I have the shapefile here. I don't care about the name right now. I just want to use it to have a reference. So in QGIS, I go to that folder. I have it here. And then, okay, no, it's this one. And then I'll go to Cloud Compare. Additional algorithm. It's taking a bit, just let's be patient. So now it's there. You can see, oh, sorry. Well, where is it? It went to the 2020. Okay, so here is the shapefile. And this is the shapefile that I want to add. And I just add it. So here I double check in this corner that I am in the correct zone. Canberra is 55, Sydney 56, Adelaide 54, for example. And each location in Australia and all over the world have their own particular GDA and MGA zone. Okay, so it's there. Look, as you can see, is the national algorithm. It gives you an idea where are the things happening. So now I'm going to add a background because a base map will help me to identify. So I'm adding the base map from this plugin of QGIS for base map. The name of the plugin is Quick Map Services. So to install it, you just need to go to plugins, sorry, map. It will open all the oh gosh, where it is? Okay, here, and you can see the install, and I installed the quick map services. If you want to, you can find it here, quick map services, and as soon as it pop-ups, you just click and install it. So I will add the simplest one, which is the Esri satellite. So then you have the Esri satellites, as you can see, the data set is added properly there. So that is what I want to georeference, right? And what I'm doing this because I need to have a special reference and the correct zone for projection. And then I need to have some aerial image and it is properly projected there. So what happened is, like, once we have this, you can see, then we can add our TIFF. For example, I suggest saving as a TIFF in Photoshop and then add it here. Let's see what happened. The TIFF is just simply lost. It doesn't have any special reference, right? And it doesn't have coordinate, it doesn't have location, etc. Nothing. So what we're going to do is we're going to start the process of georeference. So to do that, we just go to raster and georeferencer, and we need to add the TIFF. In this case is training, no, teaching here, cloud compare national algorithm, and we're going to grab the TIFF, okay? And this is the one we want to georeference. And we're going to start georeferencing. Please set transformation type. We want to set it to the MGA zone and the output raster transformation type. We can use the thin plate spline, nearest neighbor, no compression. This will be the output. So the output we can put, we can create another folder and call the folder Georeference. Okay. Go there and then edit it. We just change the name, national origin ref, and we save it, and then put OK. So then we need to start this defining points. So we can add points. So we need to set points in the image that correspond to points in the ground. So for example, we can say that this point here, it's asking from map canvas. So we just selecting the map canvas. Where is that point? Is here, okay? And we say that point is there, right? Okay. So that point corresponds to this point. So then the other point that we need to find is this point, common point. So that's why it's very important to have an accurate image here. So you can see here, you can go on detail and say that this point here, map on canvas, again is this point, and say okay. Now we go to the next one, try to search for points that are very easy to identify or locate. So for example, here in this corner, it's a bit tricky. Okay, so we need to find the point properly. If you're not sure, better not, just to avoid issues. Say that, look, this point here is the corner here, as you can notice, right? So we can also get this point and say this point here. I'm doing this very quickly, but you have to take more time. And then from canvas, say that okay, and then then we're gonna move towards the corner. So this corner here is up on canvas, this point, and we say okay. Then just continue to other points. Look at the end of this, there is here. So as you can see, this corresponds to this curve. So well, to make it simple is I'm saying this point, oh sorry, this point here in the canvas corresponds to this one, okay? But you have to be very precise, okay? And here we're gonna try to find more points. You can use buildings, as you can see, it's easier with buildings as well. So we can say that this point in this part, it corresponds to this one, okay? And this point here in the canvas corresponds to this one, okay? So we have 2 points there, where are quite good. We have more points here that we can use as a reference. So you start doing more, as many, the more the better. Okay, in canvas is this one. Set okay. Then you can find the lake. I couldn't find properly the lake. The lake is a bit trickier because you don't know where is the boundary of the lake. But you have this structure, which is good. So this structure corresponds to this point here. And then let's try to find points across the entire area because that will make it more precise. This corner is very interesting, very important to get. So that corner should be after, it's not that easy. It should happen after this is here. So that corner is this point. So we just put this corner, this point, okay. And then if we can get one more at least for this corner here. Here the arboretum is easier because you have this sort of references and points. As you can see, there is, for example, the end of this point here is here. So this one corresponds to this one, if I am not wrong, okay. And then you can see that somewhere here I would like to. So this is this one at the end of this here, okay, and then one more. So it's at the end, one more here. So this point corresponds to this point, okay. So I think we have many control points, as many as possible. And perhaps one more in this corner to avoid distortions in this corner. So let's find something nice in this corner. This corresponds to, I think it's here. Okay, so we come here and we do it again. Point. Okay, it's not very precise at this point because I'm just rushing, but you may want to find something better. Okay, this is another one we can do. Yeah, this one. Okay. So once we have done this, we have all our control points, and you can save them if you want, and then you just put start georeferencing. So it starts the processing. So as you can see, the image was kind of georeferenced. Save the points. We can compare how precise it is. It's relatively good. As you can see, it's quite good. Now, another thing I would like to do is, now the image is georeferenced, okay, in here. We just can save it. We can export it like that and use it in Cloud Compare. We can crop it. Crop it means that we clip along it, but if you want, we can do it. So we just transfer the points that are correctly there. And so that is another possibility. We can do that. I will show you how to quickly do that. Or we can also just keep it as it is or export it. So what I'm going to do is I'm going to clip it. So to do that, we need to create a vector. Raster, no vector. We just need to right click. Sorry. Sorry, vector. And it was not vector. It was layer. Create layer, and then you can put new shapefile layer. So what we're gonna do is say arboretum, and we are gonna use, we're gonna call it as a polygon. That's good. The zone is 55 because it's Canberra, and the name, we don't need to create more, and just put OK. The layer, okay, it was an error. What happened? Layer, create layer, new shapefile layer. Okay, and layer is arboretum. I want to have a polygon. Additional dimensions now 55. The name of the field. We need to add a field. We can call it height. Or distance. We'll create one field. And let's see if this time. The problem was not that one. Okay, you don't need to use the field. It was I didn't save in the proper place. So we need to find where to place. So it's teaching YouTube, cloud compare, national arboretum, and I put georeference, and I will put arboretum .shp and save, and then put OK, and then the layer should be properly created. So it's here. Then what we're going to do is we're going to start digitizing. So how do you digitize the arboretum? Easily, you go to this pen, and you put toggle editing. Then you need to choose this one, which is add polygon. Then we need to start clipping everything or creating the polygon. So we want to have this polygon. Sorry, there. I'm just doing this very quickly. You can take more time, or you just can find already the polygon ready for you. This is what I want. So I'm digitizing all the area that I want to show. I don't want to show the rest. And this is the information that I want to effectively transfer to a point cloud. So the process takes a bit, but it's not too long. So once you have done this, okay, always don't go till the end. I will crop it up to there. As you can see, it's pretty straightforward. I'm just creating the, here. I'm just creating the shapefile that I'm gonna use to clip my map. Okay, and then it comes here. Let's say like this. Okay, we can click it there, and then we put an ID 1. Don't need to worry, and then we save, and then we stop. So you create the boundary. Okay, so we can alter the color of this boundary to see it. Change the color. We can make it transparent, right? Put OK. So now it's transparent. We have the boundary. So now what you just can do is clipping, and for doing that, I just can click here. Clip raster by extent, which is this option. Yep. Or we can go to raster and then go to extraction, clip raster by extent. So we just can click there, and appears this. So the input layer will be our national arboretum ref. The clipping extent should be this arboretum. So we just drag it and put it here. Then no data value, we just can put no data, or just leave it not set, and clip extent. Then this is what we're gonna save it. So I wanna save to a file. We're gonna put national arboretum instead of that clip. Save, and then we should run it. Okay, it's done. Now we can compare. We can turn off all the. So the clip is funny. This is something that is happening lately in, I don't know why, in QGIS, that not doing the clipping properly. I found I couldn't find a proper reason for this. The clipping works better in ArcGIS. I can show you how to do that as well. But I don't know why it's doing this. Let's. It's because this is by extent or calculate from layer. There, I think the mistake was because I used the extent, so I used the longitude and latitude. So what we can do is just delete this to avoid overriding. Okay, so we go to the georeference. Oh, where it is? Here, the clip, and we delete it. Now we cannot delete it because it's here. Remove it, then we delete the clip. Okay. So once we have to start over again. Sorry, raster, extraction by extent. But here we put calculate from layer and we choose the layer algorithm rather than grabbing the extent. So, okay, let's see if it works. If it doesn't work, again, we just do it in later in ArcGIS. So let me save to a file, and then we're gonna call again clip. Okay, run. It didn't work again, so there is something there I'm missing, so don't worry about it. Okay, we just have the information there. Okay, and so what we can do is we'll show you how to clip in ArcGIS. So in ArcGIS, the process is different for georeferencing. I will start now the process of georeferencing image here. First, you need to connect your folder. So I think you go here and you add connect, and then you choose. So in this case, I'm going to box where I have my information. Training. Oh, sorry. To cloud compare national algorithm, and this is the one I'm gonna add. So once I have this, it should be displayed here, all the information. It works a slightly different georeference. This clip is not good, it's just deleted, okay? So how to do it? Again, we have the TIFF, say yes. And look, it doesn't have a special reference, anything at all, okay? So what we do is we add again the shapefile. We click here, we say zoom to layer. We do this, we check the properties of the layer. Just okay, so here is the general. So in the source, we see that it has the GDA 1994, but it's not the best. So what we need to do is just remove everything. Just grab this and put it into the correct projection. So what we're gonna do is define projection, data management, and then we just grab it and we choose a different one, which is the projected. In this case, we choose national grids, Australia, and then we put the GDA 94 or the GDA 2020. Now we're using the 2020. We can use the 2020 MGA 55. This is okay. So we are selecting and we put okay. So now it's projected there. So we see the properties. It's taking a bit because I have several software open. GDA 2020 Zone 55. So it's correct. Now what we can do is add the base map. And just click here, base map, and then we chose imagery, which is a satellite image. And here, because using the server, it's a bit slower. Okay, so you just, there is a reason there is not showing. Remove. Let me see what's going on. Again, add base map. Let's try this image with labels. If it is not working, it's because I have some lack of memory. Okay, I have lack of memory, or the server is not properly connected. So in this case, what we're going to do is not avoid this. We have the algorithm. Add the algorithm, and we check what it is the special. Notice that the algorithm is the shapefile that I created with the QGIS. Okay, is correct. So we just put zoom to layer. Is there. So what we do is now we add the image. Say yes. So this image is, remove the original image. So the image lacks of location. You just right click zoom to layer, and then you can see it's like it doesn't have the proper location. It doesn't align with the algorithm. So algorithm is already have the location. So could be also the base map. In this case, my base map is not working because I'm not be connected to the server, but in your case may work. Otherwise, you just use that boundary. Okay, so what we're gonna do is just go here to something called georeferencing. If you don't have this tool, you just right click here and you turn on the georeferencing. Look, georeferencing. And then you need to choose the TIFF or the PNG or JPEG. TIFF is the best. And then you start adding control points. So our other option is the viewer and the same, and then start working with the viewer. And then you can put side by side or link to main display or something like this. You can also put this option is view link table and show where are the locations, but then we can start putting points. So if you know the points, this is one of the points, and you just right click here and you put zoom to layer, and that point corresponds to this point. And again, zoom to layer, and as you can see, this doesn't help, so I put no color. Then the other is just another point here, and then again to the algorithm, zoom to layer, and that corresponds to this point. I think so. Yeah. And then it makes your life much easier because you can start connecting the points easily. Okay. And then you need to go to my zoom is not working. Sorry. Zoom to layer. So then you can start selecting other points, like for example, zoom to layer. Okay, this point, it is this one. And then you start correcting all the points, another point here, and so on. So the more points you add, the more precise it will be. As you can see, you need to correct several times until your points are done, and so on and so on and so on. Okay. I think it needs 1 point here. That's why it is behaving like this. So it's good to start with points that are opposite and then start correcting. Again, zoom to layer. So you see there is roughly done. That's an option, and then you just put rectify, and it will rectify automatically that image. Okay, so that's not a problem, and it's happening the georectification right away. So it works similar than in QGIS finding control points and georeferencing. You try to be precise, so for that you need to work on the correct points. Always it starts from opposite points, so until you get this. Okay, now let's wait for the rectification to happen. And then it's asking you save as, and then you put It's taking a bit. You just put the name and you just rectify. Okay, let's forget about this. Let's assume it happened, or you can put update your referencing and it works pretty similar. Okay, this is overriding. One is done that, I want to show you how to clip. So you remember I have this algorithm, the one that I put before, and it needs proper georeference. So what we're going to do is, again, define projection, data management. Oh, sorry. We need to grab it, put it there, and define the zone, 55, okay. So it will be there, correct? That's good. Now we're gonna do the clipping. So we just need to just put clip and clip data management again. And then we chose our, I think was the edited. No, sorry, reference. That's correct. And the output extent is optional, but in this case, we need to have the algorithm. And here we use the use input feature for clipping geometry. So it's the feature what we're going to use to clip. Then we chose the location. So we just have to do it. Come on. And I just want to find the location, georeference, and then we're going to put it the name clip, save. The no data value, we're going to put no data instead of the 256 because that's the RGB color, but we put no data, okay? And maintain clipping extent on. Check adjust the number of columns or rows to the resample, okay? And then we go to environments. We choose here the cell size. So we can use and specify, and I put 1 meter. Okay, or can be 0.5, whatever is the size. Okay, and then we put okay. So the process may be happening right now. And now it's done. As you can see, the clipping happened exactly within the boundary. Okay, we can double check that again in QGIS. Oh, it's here our QGIS. So if you grab QGIS, you have here the clip, you add it. As you can see, the clip now corresponds with is within the boundaries. So having said that, now we can start the process of coloring our cloud compare image. So this is my algorithm, my model. And then what I can do is open it here. Georeference, because there is already georeference. And I need to grab the one that says clip if. Okay, open. Import raster as cloud or as texture quad? No. Just a texture. And we use the last input. Last input is this one. So they will overlay it with each other. Yes, to all. So as you can see, let me put it in angle. So they are overlaying each other. Okay. As you can see, there are my Sketchfab model is bigger. So if you put on the top, the model it's slightly different. So you need to try to match. It's an option, or another one is you don't match and it's just looking like this, you know, and you just transfer the values that you have. Or you can do the segmentation later, and I will show you quickly how to do that. So once you have this, I always make a clone, not to destroy what I have. So I have my clone here, correct? And then what we do is we choose that model, and then we put edit, scalar fields, and then we put interpolate from another entity. And we need to select that entity, sorry. So we select the mesh and this, and then we put edit, scalar fields, interpolate from another entity. And then we choose, oh, I made a mistake. Order of selection is important. So let's select the mesh, this, and then edit, scalar fields, interpolate from another entity. Please select one of the several entities. Okay. I want to select the mesh. Why is not allowing me to? Let me see. This is a mesh. Okay. Okay, what I did is when these two are like this, they don't work. So I made a mistake. In fact, what I should do is File, Open. Made a mistake. I'm correcting. Grab the TIFF. Oh, sorry, the TIFF, and I will bring it as a point cloud. So I say yes. Let's input yes to all. So I want to have a point cloud. So if we turn off this, so you will see here it's the point cloud. So after having done this, we need to rasterize this. Okay. Sorry, that's the step. We rasterize and we put the RGB as an active layer of gray. We create a mesh. Oh, well, something happened there. Just let me. So something happened that I have to restart the cloud compare. We're back here with the cloud compare. So I chose the point clouds. When I imported the point clouds. Sorry, the GeoTIFF as a point cloud. Now I'm going to rasterize it. And in rasterize, the step is the size of the grid. And then you put RGB. I'm just following the steps I show in my YouTube video before. So more detail you will get in the video. So you just put upgrade grid and then you will get the grid and then it should be okay with mesh. It's creating the mesh right now. So now they're there, correct? Okay, now it's done, correct. So this is the mesh. Now we need to open the point cloud. That's input. Correct. And now what we're doing is we grab the mesh, grab the point cloud, and then we put the scalar fields. Interpolate. So destination will be it's better to put it in this angle, sorry. As you can see, okay, here, destination should be chosen after. So the origin, destination, doesn't matter at the end anyway. Scalar fields, interpolate. Oh, sorry. This and this only. Edit, scalar fields, interpolate. And then look, destination are my vertices or points, and the source will be the image at the bottom. And you say you can swap as well, and say okay. So then you choose which one. You just put average height. This is the name they put it, okay? And then you use different methods. A good method is the nearest neighbor or nearest neighbor, and you put 8. So you know that the information that will be transferred is the calculation of the nearest neighbors. Or you can put a radius, just simply 1 meter. And you can use the median, okay? So depending on the data, if it is information like a distance, specific distances, or topography or temperature, it's good to use this. If you're going to use or transfer information that it is just simply the RGB, I will put 2 meters because that's the radius, and that's all. I will put here median and say okay. Oh, what happened? There is an error here again. Edit colors, tools, no, color fill. Okay. Interpolate from another entity. You say okay. Average height. Okay. And normal distribution. Let's see. 2 meters. No, it's not working. Now let's do it. Another method. Let's use. Sorry. Okay. And then we grab average height. Nearest neighbors. It's also not working. Let's go and grab another method. Maybe because we're transferring color. Average height. I put 6. Average. No, it's not working. So something is happening. We need to see what's going on. Okay. Okay. We're going there to see what's going on with the grid. Let's see if we, instead of the grid, I don't know where it is the error coming from. Another possibility is to use the point cloud and transfer from another point cloud. Let's see, edit, color field, interpolate from another entity, and no, we cannot because it's just a point cloud. And it is completely flat. So what we want is just to transfer the information. So I think the best is just the vertices. And this, and it should work properly, but let's check here. Is RGB color field? That's the reason. Average height, no, is average height is just wrongly calculated. Because the image is an RGB, so we cannot. I found the error. So okay. So if we put an scalar field and we choose the high grade, we will have some problems because this is, it calculated the average height, so it's the wrong estimation. So what we need to do is just to transfer the RGB back to this using just the normal method of LAS tools, because it cannot transfer this information because it's not numerical. It's RGB color. So we can edit. We can try another thing. We can see if we can rasterize again. I will put 2 meters because to reduce the complications. And then I put active layer RGB. Okay, so this is our range. And fill width is empty. The empty cells will be leave empty. Upgrade grid. And then after that, I will create a mesh again. So maybe this will create in the problems. Let's see, mesh. So let's wait for that. It just created, it was created. So it's here, the mesh, vertices, sorry. And now let's try to do it again to see if it works. If not, we need to do only the other version. So edit, color fields, interpolate from another entity. Okay, number is high, okay. Okay, no, it's not working. It's simply because we're just trying is just to, this color field is an empty value. Because the RGB cannot be transferred as a color field. So it didn't work this method. I was thinking it would work. We can try again RGB 2 and then go to the direction resample input cloud, no, average height, and leave empty, upgrade grid. Okay, because we cannot interpolate numerical RGB values into numerical values. So this method doesn't work, the second method. What it works is the first method using LAS tools. So what you need to is just follow that step. So LAS tool is LAS.Colour. And again, it's just this, very straightforward. You just grab the algorithm. So in this case, what I'm going to do is, before doing anything, I'm going to copy the model. So National Arboretum of Australia, Arboretum, Sketchfab 1. Yes, we copy this. And we come here to the Arboretum, National Arboretum, paste. Okay. So this is the one that we want to do. So we can change the name and we call it for color. So divide it. So we come here and we choose the algorithm for color. The ortho image is the image that we have here, georeference clip. Okay. Additional line no, and the output. Save to file, and then we're gonna put a name, and we say colored. So because it's already done, assuming it works. We need to put the result to LAS extent. Okay, save, and then we run it. So what we're doing in this method is just transferring. It seems it worked. So now we come here, we turn off all of this, and we open that file. It should have worked. Let's see. Cloud compare, and then we go to National Arboretum, color, apply just less input. So remember, it's very good, it's very interesting that the interpolation didn't work, but I assume this method, it worked. So what we did here is that we managed to transfer the colors from the georeference image into the point clouds. Let me turn off this. So the second method, it worked. So it's very interesting. We couldn't at the very beginning to transfer the color from the mesh. For some reason it didn't work because you cannot interpolate RGB information. For that you need to use LAS tools, okay, LAS.Colour. So there is a YouTube video on how to install LAS.Colours, but now you see it works. So now we managed to transfer the map that we originally produced and we originally found online, and then transfer it into the, let me find it here, sorry. This was the original image, where it is edited. So this was the original image we found online, It could be any other map, and then we color it, and we brought that into the QGIS. We ortho rectify, we crop it. You need to crop it if you want. If not, we can keep it. We crop it with RGs, and then we transfer these using LAS tools. As you can see now, the model has the colors from the map. So this may be very useful for people who are doing other type of studies. Now, if you want, you can select all, clip also this LAS tool. So we open it. We just grab the arboretum shapefile, look, open, LAS input, yes. And then what we're gonna do is gonna do the segmentation of the color. So we segment. How we segment? Click like this. Choose here the existing polyline. This is for clipping. We just keep something wrong here. No. So the polyline is not aligned properly. That's the problem. So what we need is to delete all the previous stuff. We need to open it again. Where it is, arboretum shapefile. Yes. Oh, sorry. Arboretum shapefile, and then put suggested just to all. Now you put open again the model, which is color, and then we are going to put last input, yes to all, and this should align properly. There are a lot of tricks with this software. Oh, it didn't work as well. Oh gosh. Okay, we need to open. Today the things don't want to cooperate. We need to open it again, the cloud compare. It's easier. Close the window, open again from scratch. Okay, that resets the graphic locations of cloud compare. Again, the color, yes. Okay, that's good. It should work properly this time, please. And now we open the shapefile. Shapefile, oh sorry, is the national algorithm. Okay, this one, georeferenced algorithm. And then we put the last input, which is corresponds to this. Just to, so now they are aligned, I think, in a better way. Okay, so now we use the segmentation. We club, we segment, we choose the polyline, and we go to the top. They don't align. What is going on here? Okay, let's go to the top view and segment polyline. Choose the polyline. It's good. It's correct. Now we do the segmentation. We just keep the interior correct. That's how it is. That's how it works. And done. And then so we have, as you can see, interior part, the exterior, and the interior part. This is the one we keep. Okay. And yeah, we just did it exactly as the spatial extent. Okay, and then we save this as the clip or whatever is the name we want to use. Okay, so in this way we transfer, we clip. There are a lot of steps. We made mistakes in the process just to learn that we cannot use some type of interpolation like the scalar fields, because we cannot interpolate scalar fields that correspond in reality to RGB. So that it is one of the problems that we have, but we learn in the process. So we just need to use LAS tool to color it and everything worked properly. So that's it for today. And if I will create new methods, new workflows to work with Cloud Compare in future, and so stay tuned. Thank you very much.